family mode.
Hello everyone, are you able to hear me? Great. So everybody is able to hear me. Hello Lux, hello Lloyd, hi Jairam, Shravna, David, Ravikant, Sanjay, Tushar, Rajesh, and Sandeep Mane. Great. All right. So the full class is ready, and let's start with what we had left yesterday. Okay. All right. So do you have any questions related to what we had discussed yesterday? All right. Hi Suresh, hi Vidya. Great. So do you have any questions related to the uh, any other thing before we proceed with our discussion of this particular problem? All right. Regarding that FSCK command, Jairam, please send me the error log again, because what I noticed was you were trying to access a file which is local file, not the file in the HDFS. That was the problem. All right, we can discuss it offline. Any other question? All right. Sanjay Tandon's question is, I have heard about data lake, data reservoirs. What are these in the context of big data? So these are new terminologies that define the way we had data warehouses to give them a newer name which have different technologies. We call them data lake, data reservoir. Basically, when you have a place, singular place to hold the data, that's called either the data lake or data reservoir. Also, these terminologies will keep on coming every new day. Okay. And yeah, I also need to go through them again because everybody has their new terminologies, and they try to be as vague as possible. All right. All right. So, any other questions before we proceed? Good, good. So now let me ask you this one. So yesterday we discussed about the simple solution of doing it programmatically, as in we are loading it into the memory. So what problem do you see with this? Or let me ask you the other way. What happens in the case where Lord of the Rings books grow to, let's say we are trying to use the same program for text which is in 10 GB, or we are trying to churn a text which is 100 gigabyte. Will this approach work or will this not work? Will the same approach be valid for 100 gigabyte data or not? All right. Sanjay says may not work for big files in memory filled arrays. Correct. Because hash table will consume a lot of memory and everything is the memory. So no matter what you do, you will hit the memory upper limit. And David says that it will take too long to finish. All right. All right. Good. Good. Thank you, Sandeep. Sandeep also is saying that hash table will consume a lot of memory. Okay. So basically, the main problem with this approach was it cannot process data beyond what can fit into the memory. Memory, when I say memory, means RAM. Because in this approach here, when we say we are creating a hash table, it's an in memory data structure, which where we are loading things into the memory. Now, what would be your approach to solve this? In case the memory is the problem, what are the other approach you could take? Anyone? All right. So we started with the problem of Lord of the Rings, where data was in MBs. That was easy to solve using dictionary. But in case, in case the data starts growing beyond what could fit into the memory, how will you solve the problem? Anyone? Sharna says using distributed computing. Sanjay says queues, splitting the data over multiple machines. Brilliant answers. Check if memory is full, save the result back to the file and take next data. This is interesting, Sandeep. And how would you, if some part of the data is in the disk, some part is in the memory, how will you check? How would you check? How would you increase the frequency? Because you require full data into the memory, only then you can do the frequency computation correctly. All right. So Rajesh says cache to the disk whenever possible. All right. Tushar says we can use multiple machines to process the data. I guess distributed computing could work. Good, good. Now let's take another approach. So this approach is good if your data is in MBs. I mean lower MBs, not upper MBs. Like it's, if it is in thousands of MBs, it's of no. This approach is of no use. All right. Now let's take another approach. So this is an approach in a practical sense where this is the most practical approach. Probably some of you gave this answer yesterday. You break the books into one word per line, import this data into database, and then do the group by on this table and do the aggregation. Does it make sense? So for say 10 GB of data, do you think this approach makes sense to you? So is this approach clear? The approach number one was using the in-memory. Second was using the SQL. And SQL takes care of the memory management by itself. Sanjay says it's slow and 10 gigabyte will take time and not scalable. That's Rajesh's answer. Okay. So David says yes, could work for larger sizes. Shravana says the sorting and indexing will take a lot of time. Correct? All right. And Savna, how much do you think it will take? How much time do you think it will take to index 10 gigabyte of data? Suresh says it is still difficult to break. Laksh says that it's good for less than 3 gigabyte data. Brilliant answers. It will take longer time hotspot on one table. Correct, correct. Sarvana says it will take 8 to 10 hours if it's 10 gigabyte of data. Actually, it won't take that much, but yeah, it would be in hours, definitely. All right, brilliant, brilliant. So there is another approach around the corner, which is related to a Unix command line. Okay. So those of you, how many of you are comfortable with Unix? Okay. So Lux, Lloyd, David, and Suresh, Karthik, and and Jairam, all of you are familiar with Unix. So are you able to figure out the meaning of this command? Tushar is also comfortable. Great. So do you want me to give an overview or overview of pipeline and filters? Because that would be used in case of Hadoop streaming jobs as well. All right. I think it's better in everybody's favor that to give the description of this particular full command line, let me break it down and explain to you from the perspective of Unix. All right. Because most of you who has even worked on Unix have not, not too much of confidence right now. So, all right, I'll just break down this command and try to explain it. And those who are comfortable with Unix, so they need to have a little patience with it. All right. So let me try to go through this. That will be helpful in case of your um, what do you call Hadoop streaming as well. We'll take one example of word count using shell. Okay. What? All right. All right. So you can see here that so when you log in into Unix terminal, this is where you type commands. Okay. You can say ls. Ls means the list of files, and this is local files. All right. Now the important aspect which we I want to discuss today is how does the pipelining work. So a command can give the output and take the input in two forms. Command can give the output in two forms and take the input in two forms. So ls can either take so a command can either take the argument from stdin where you type in the data, or it can take input from the command line arguments. Okay, like the way I have said ls minus l. Minus L is an option which is basically an input to the command. Similarly, if there is a program such as cat, okay, so cat, whatever you type here, it will basically type it back to you. All right. So cat is a program which is taking the input from you and giving output to you. Okay. So the other form of input stream is stdin. The next one, the output of a program can either be given to the screen, which is called std out, or it could be given to another stream called std error. Okay, so a program can write to two streams and can take the input from the std in or the command line argument. All right. So now coming back to these streams again. So one program who is taking the input from you, like we just showed you that cat was trying to take input from you, it can also take the input from another program. All right? It can take the input from another program. Let's take the case of WC. Okay? WC. So WC is word count. I mean, it tells you how many lines, how many words, how many characters. Okay, so in case of ls, now when I say ls, pipe is this vertical line, pipe and wc. This vertical line, you can see it on your keyboard just above the enter key. All right, so when you say ls pipe wc, it means ls, instead of giving output to you, would give output to wc, the word count, which essentially means that for WC, the input, instead of coming from you, is coming from ls. Now if you do not type ls, so now WC is expecting input from you. You can see that, and the moment you say control D, it ends the input and gives the result. So you can see the difference. Make sense? Now the result of all of this could be further pipelined as many times as we want. Okay, so we could keep on saying WC again and again. The result of one WC is going to another WC and so on. So you can see the second WC gave us, so first WC was giving us some other result. Second WC basically counted that there are three words and how many letters, including all the spaces. It's around 24 letters and only one line. You can see that. So this is pipelining of the data. Now there are many commands such as grep. So what does grep do? Grep basically filters the data. Okay, so you can do man grep, and you can also do man awk. Awk is also a filter. All right. So let's say that I want to read a file. So what will I do for reading the file? Let me also demonstrate something. Minus cp. Sorry. Let me bring a file from Hadoop, which I know for sure is something I want to work upon. Or can I do something else? Cat, looks like there is a bit of sloppiness in the connection. So we can say cat test .txt. So this is it's a new file. It has only 4 words in it. Okay. Or what could I do? Let me bring our real data. Hadoop fs or cp dot student slash sgiri slash, is there something? Hadoop fs minus ls and slash data. Let me bring some real data which you would appreciate. So slash data is the folder which you cannot change, but you can read the data from there. Okay, it's in HDFS. I'm saying copy to local. I'm bringing this file from there to my local folder. Okay, so I'm saying cds giri, and here you have. Make sense to you? Now, when I say cat big.txt, I can also put a pipe more. More basically gives us the page-wise option. If I had not put more here, there would be screen blindness, as in lots of text could have scrolled on my screen, right? Because it's a big file. Now let's say I want to I want to break this file into one word per line. So what would be my approach? I will use a command called sed. Sed is another command from Unix which can replace something with some other thing. Okay? Sed, although sed is a very big command, it has lots of options and it has lots of grammar. The form which we are going to use it is in the form of replacing one word with another. Alright, so we can say sed, and s here means substitute. So something with some other thing. What is it that we are trying to replace? We are trying to replace space with new line. Okay, and so this portion, the first, the first character here between the two slashes is something which you want to replace with something with this. All right, and I'm saying now you can see that it has been replaced. Good. I should have put more because I could have avoided this screen blindness. All right, let it complete. What can I do? Is everyone okay with the pace I'm going, or should I go faster or slower? Or what could I do is I could just kill the terminal. Or should I wait for it to finish? I don't think it will ever finish because there are too big text. It's like millions of words. Yeah, I tried Control C Lite. It did not work. If I use Control D, I might exit. Therefore, I was not, I was a little worried about. All right, so here we are, and yeah, this is where we were. So we are trying to replace this with some other. So I can say more and it can stop. All right, now again, the next thing we want to do is we want to replace these special characters with something else that we can do later. Now there is a very interesting command called translate. When we want to translate character ranges from one form to another, we use tr command. We will say a to z, replace it with capital A to z. Okay, this is what we are going to say, basically converting lower cases to upper cases. All right, also we want to do is substitute anything which is anything which is non what do you say, actually this thing we should do in the beginning itself, cleaning up, we can say anything which is not A to Z or 0 to 9. Okay, any number of those, just replace it with new line. So this is what we are trying to do. Ouch, it did not work, looks like. Anything which is not A to Z, 0 to 9, and any number of that should be replaced. And here there is a switch we can use called minus R. You can see that? Alright. So we are piping the data. Okay. So output of cat, which is reading the big.txt, instead of dumping it on the terminal, it's sending it to sed command, which is basically replacing everything which is non-alphanumeric with new line. Okay. Any number of non-alphanumeric characters appearing consecutively will be replaced with /n. Afterwards, we are translating everything into uppercase. And now is the time for magic. Now we are going to do a sort. Sort basically sorted the data. Sort sorts the data in increasing order. You can see so many blank lines there. All right. Now the next step after we have finished sort is we can say unique. So we took the data, we first replaced all non-alphanumeric characters with new line. After that we translated A to Z to capitals, and afterwards we replaced afterwards we replay sorry after we have converted whole file into capitals, what we are doing is we are sorting these words. Okay, we are sorting these words using a command called sort, and then we are using unique because unique cannot work on non-sorted data. Okay, unique is a command which gives you the distinct words, but if you put minus c on the command line, then you will what you will get is the counts of all the unique words in the file. Now you can see that. All right. Lloyd's question is what does G stands for in sed command? In sed command, G stands for even though this particular expression is matching multiple times in a file, replace it multiple times. Don't stop on the first replacement. G for global. All right, Vidya. Vidya also had the same question. Sanjay says space is not there. When I say space is not, you can see here I'm saying not of alphanumeric. It's a regular expression which says anything which is not alphanumeric should be replaced with /n. And what does this minus r represent in sed? It says regular expression. Sed would consider these strings to be substituted as regular expression. So it is actually Karthik. It's actually showing the word. You can these are the words. Just because when sorting, the sort command has brought the numerics first. Therefore, these sounds like numbers. These are the words from the file. All right. If you put tail, meaning the last commands, you can see the last words. All right. You can see these are the last words. Good. So we were able to sort using this data. Now, problem with this approach is this sort command will consume a lot of memory, and that's when we use a option like sort minus s and 1 gigabyte. And this option is beautiful in Unix because it only would consume say 1 gigabyte of memory, or we can also say 10 MB. Sorry, it has to be minus s. Okay, it can do it in the 10 MB itself. All right, is everybody comfortable with it? Now, after the whole work is done, we can further sort it, and we can this time say sort minus numeric and also reverse order, and then save it to a file. Let's say we call it WC, word count. Arrow means we are trying to save the result of whole pipeline into the word count. Okay, now you can see the one which is most frequent is the, and then is the space because number of all the new line blank lines have been counted as space here, because there were blank lines where there were consecutive. All right, Rajesh, sort minus s, when I say sort minus s 10, it meant that we are only consuming that much of memory. Let me go back to the command. So this command is clear to everyone. Cat big.txt, meaning read this big.txt and dump it to the std out. Right now the std out is going to sed instead of coming to the user's screen, right, because of the pipe which we have put here. So sed replaces non-alphanumerics with new line, and then the output of sed coming, instead of coming to your screen, is going to tr. Okay, and the tr is translating it to caps, and then is our sort minus s 10 MB. 10 MB means do it only in 10 MB. And then again we are saying unique minus c takes the sorted input and prepares the unique characters, unique words. Okay, this means that if our data is say this, that, this. Okay, if you run unique minus c on this, you will be surprised to see the result. Okay, this two and that one and this one again. I hope you got the idea. The unique command expects the data to be sorted, and its algorithm is simple. It keeps on counting, the count keeps on increasing as long as the word is same. As soon as the word changes, it resets the count and starts counting again. And that's why you see these kind of result. So this came twice, that came once, then this came once. That's why we need to, if we sort this data, and then we do the unique. Okay, we do the unique. You can see that this time the result is correct because unique minus c expects the data to be sorted already. All right, now the output of unique minus c is being sent to, let me just check if we are recording or not. All right, we are recording already. All right, now we are again sorting. All right, let me just remove the last sorting. That was just for demo purpose. Okay, and we just rename it to 1. Now this word count will give you, I mean, the result in no particular order. I mean, the result will not be sorted by the counts. Instead, the result will be sorted by the words that we are counting. All right. Now, question to all of you. There are two, three questions to all of you. First question, out of this whole pipeline, this pipeline, you can see this pipeline clearly. Let me, if you want, I can copy it. I can copy this here. Out of this pipeline, how many commands are there? Can anybody tell me quickly? Out of this command line, how many, in this, how many commands are there? Ignore the last one. Ignore the last one. In this, how many commands are there? How many processes will get executed? One, two, three, four, five. Correct. We'll be executing approximately five processes when we run this pipeline. Correct. Next is, out of these five processes, cat, sed, tr, sort, unique, which one is the most intensive process? Which one is the most time consuming process in this? When I say time, I'm talking about CPU time. All right, correct. The time will be mostly consumed in sorting. Okay, you can also think about, I'm talking about CPU time. So CPU or the memory will be mostly consumed in sorting. Why? Because sorting is the only algorithm which is not linear, meaning the time taken by sort does not increase in a linear fashion, but linear fashion in the sense that on the input. Meaning, if 10 records were taking 10 milliseconds, 20 records will take more than 20 seconds. Alright? So sort command is far more intensive than any of the other ones. So it's not a binary search, but it's, I think, it's a heap sorting, I think. Right? I think it's a quick sorting, not heap sorting. I think it's a quick sorting. I'm not aware about exactly which algorithm sort uses. So Anindita is saying, but once parsing is done by SED command, it becomes easier to sort. So for sort, whether the parsing was done or not done, it's equal amount of headache. Okay, SED command is linear. Why? Think about this. If I ask you that these are the 50 names, can you just clean up, just remove the punctuation marks of these 15 names? Okay, then I ask you that these are the 15 names, can you arrange them in certain order, in an increasing order? Which one can you do quickly? While cleaning up the data, you just have to look at the data only once. You start from the beginning, you go till the end. But when you are arranging the data in increasing or decreasing fashion, you will have to look at the data multiple times. Okay, that's what when I say non-linear complexity, it means that you are not looking at the data only once, you are looking at the data multiple times. All right. Make sense to you? So this is the most simple explanation I could come up with for complexity, that when you have to just look through the data only once, we call it a linear algorithm. But if you have to look at the data more than once, it is complex. It takes a lot of time. And sorting is one such example. Good. Everybody clear about this command? All right. So a tough question for all of you. Okay. A question is, are these five commands executed in parallel or in sequence? Good. So uh, everybody says that it's in sequence. Good, good. So conceptually, yes, it is in the sequence. But those who are from computing background would realize that SED will start consuming the data even before cat has finished printing. So do you think SED waits for cat to finish? So do you think SED waits till the point cat finishes its work, or SED can start in parallel while cat is printing the data to this STD out? Yeah. So does STD start processing the data as the cat is also working, or it can go with cat command, correct? Because as cat is printing to the screen, STD has started processing. Okay. and and the output of SED, as it's being done parallelly, is being parallelly processed by TR, and all that the output of TR is also being processed by this one. But the sort command is the one which waits. Is the duty of sort command for to wait till all of the input has been received, based on which algorithm is being used. Alright, while unique command doesn't have to wait for the input to finish before unique command starts, right? Let sort command keep on giving it the result, and unique command can start processing the result right away. Alright, so it's sort of pipelined pipelined, okay, but executed in parallel. All right. So pipeline means there is a pipe going from cat to SED. Okay. There is a pipe going from cat to SED. While cat is putting the data into this pipe, and SED is reading the data from the pipe parallelly. Okay. Now it's up to the SED for to wait for for cat to close the stream and then do something, or can it start doing right now? All right. Now here there is a relation, there is a conversation going on between the cat and SED. First conversation is that in case cat has not given the output, SED will not process the output. Okay, and in case the internal memory of this pipe is full, the cat will stop processing till the point SED consumes it. Okay, so distributed computing or parallel computing relies a lot on these kind of concepts, where one process is giving data to another process via a pipe, where if the producer of the data will stop producing if, for multiple reasons. First, if the pipe is full, or there is no data to process further, the consumer of the data will stop processing and wait for the input to come if the pipe is empty. Okay, and the consumer will end if the input stream has been closed. Okay, so this is how the pipelining work. This is a very important concept, and all these stream processing, Kafka, this, that, everywhere you will see the the producer consumer behavior so much prominent when we are doing processing of big data, or doing the parallel or distributed computing. All right. So yes, Sanjay, these five commands are kind of being executed in parallel, connected through a Unix pipe internally. All right. Did it make sense to you? The pipe thing I explained? The producer and consumer. Cat is a producer, SED is the consumer. Now, SED is a producer for TR and TR is the consumer for SED. TR is the producer of the data for sort and sort is the producer of data for unique and so on. Good, good question. So Sanjay is saying, what if one middle process fails? Correct. So when the middle process fails, there could be a few things. The process, it does not exist. The program itself is wrong, or the middle process has raised an alarm saying the data input given to me is corrupted. Okay, so the moment that happens, the middle process sends a signal, sends something like an error has occurred in the input, and all the consumers of the data, meaning the let's say SED faced a problem, a critical problem. TR will give an error saying the input stream has been abruptly closed. Okay, same is sort will also get the error and unique will also get the error. Good. So that's how it works. If the input stream is not gracefully closed and is closed abruptly, then the all of the processes which follow it will get the error. All right, did I make sense to you? Okay, though the data will flow from left to right in the sequence, but that does not mean SED will wait for cat to finish loading the data and TR will finish SED to TR will wait for SED to complete. Okay, this is to ensure really fast processing. All right, it took me some time to actually figure this out, and it was probably the most important thing which I learned about Unix piping. All right, so that was a little extended discussion on the command line. So now everybody is clear what magic is going here. All, all right. So, all right. So we discussed approach number 2 and approach number 3. Approach number 2 was SQL and approach number 3 was Unix. So do you see any problem with approach number 2 or approach number 3? Yeah? Are you able to hear me? Rajesh says that if there are multiple files, then SQL option will not work. Pre-processing will be required in that case. That's correct. All right. And same with Unix option. Not really. With Unix, you can say easily, you can say things like, you could say cat star or cat A and slash data slash something cat B and so on. We can basically put down all the files in a on the, as the argument. All right, Rajesh. Sanjay says that it's memory dependent, slow, and failover consideration. Good, good. Karthik says in approach 2 we have to insert into database and then count, which will consume time. All right. The approach number 3, multiple commands pipeline, which will be slow. Okay. Okay. Sandeep says that Unix looks more prominent unless it has limit to process volume of data. Good. Good. All right. Any other problem do you see? So in approach number 2 and approach number 3, it's very clear that it's not limited by the memory of the computer. All right, because SQL takes care of the memory issues. Similarly, in case of our Unix program, by saying sort minus s and 1 gigabyte, which means sort will not consume more than 1 gigabyte, and rest of the program anyway do not consume any data, any of the memory. So memory issues are definitely not there. The problem is the moment the data starts going beyond the RAM, the time taken would start increasing. The following would become the bottleneck, which is CPU, disk speed, and disk size. Okay, because in case of sort it tries to utilize the disk instead of in so sort minus s 1 gigabyte will try to utilize disk instead of the RAM, and that's where the this disk speed and disk size along with the CPU will become the bottleneck as the data keeps growing. Okay, the CPU will become bottleneck because sorting is a CPU intensive job. All right, is everybody convinced with these problems with approach number 2 and approach number 3? So first approach was to use in memory, as in load everything into the memory, and that generally comes under something called in memory computation. We load everything into memory and start doing the computation. And second approach in which the we are using SQL and Unix in such a manner that sort does not consume the memory, instead it utilizes the disk. Okay, it breaks down the file into parts, sorts them, and then merges them. That's what sort command does. Is everyone with me, or have I lost somewhere, or does it look complex? So Sanjay is saying disk speed is IO processing or RAM to disk swapping, both actually. Okay. When I say IO processing, basically reading, writing the data. So the way Unix sort command works is it slices the file into 1 gigabyte sizes, because we have mentioned minus s 1 gigabyte. So it will slice the file into 1 gigabyte pieces, and then it will sort them individually, and after it has finished sorting all of those it will try to merge them, and that is how it will try to sort it in a limited memory. Okay, any other questions at this point? Now what will you do? What do you suggest? Now we realize that there are approach number 2 and approach number 3, which has the problem with CPU and disk speed, and keep that in mind that approach number 2 and approach number 3, they are great and they have been going on for last 3 decades, not 3 decades, last 4 decades, more than 4 decades, 4.5 decades, 45 years. The approach number 2 and approach number 3 have been fairly successful. Now, the problem with approach number 2 and approach number 3 is the one which is termed as big data problem. When the data starts growing bigger, say bigger than few GBs, then the limitation of disk speed and CPU will start hurting you really bad. Disk speed and CPU both, disk speed will matter in the volume, and the CPU will matter as a velocity. Okay, so now what should we do? Can anybody suggest what should we do? Okay, Sanjay says divide and conquer. Karthik says distributed computing, or use with a network of computers. Rajesh says make more disk space available with fair disk speeds. Okay, okay. So Rajesh, the truth is that disk speed is not going to increase so quickly, because the one which I have hardly heard about the disks is 7400 RPMs, or there is another end which is solid state hard drives. Solid state hard drives is really a good option, but its disk size is very small. That's where the problem starts occurring. So none of these solutions will actually work for a data of size few terabytes. Okay, data of size few terabytes. And yes, SSD is also costly. Okay, now I'm suggesting a fourth approach, and you have to give me the problems with this approach. All right. All right. So whenever none of the approaches work, and our data is bigger, we cannot say that we cannot do a word count on such a big data, or we cannot say that we'll just do the word count on one of the files. No, we have to do the word count on whole data. Now, what could we do? What is it that we could do? So we devised something called external sort. And how does external sort work? So the way external sort work is split the files to the size that could fit easily into the memory or RAM. So if you have 10 gigabyte of file and you have only 1 gigabyte memory, you break down this 10 gigabyte into something like 1 gigabyte memory. And once you have sliced this data into 1 gigabyte memory, you could send to multiple machines 1 gigabyte each, and on each of the machines you could use any of the approaches mentioned in 1, 2, or 3. And once that is done on each individual machine, return the summary, return it to the launcher, okay? Return to the source all the results from all the nodes, okay? So imagine this, that launcher is sending sa re re to machine 1, ga ga re to machine 2, and 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 machine 1 and machine 2, after computing the frequency, it sends a sorted result to the launcher. Okay, this is your one box, this is another box, this is another box, or maybe launcher is on either of the machines. It doesn't matter much. Okay, so half of the file we send to machine 1, half of the file we send to machine 2. Here these three words I have taken just for extreme simplicity. These are 1 gigabyte files both, having these words. Alright. Now machine 1 gave us a result which is ordered by the word re sa. Okay, here ga re, ordered, like ga comes before re in the, if you have the alphabetical ordering. Similarly, re comes before sa in alphabetic ordering. So launcher gets these results and launcher combines them to form the results. Okay, now combining the sorted results is far more easier. Is everybody convinced with that idea, that combining the data which is already sorted into a sorted manner is easier than combining unsorted data and then sorting. Okay, so combining, let me say, combining sorted data into combining sorted files, let me say, sorted files into sorted result is, how would you do this? Let me ask it this way. How would you, how would you combine sorted files, sorted data, sorted records, sorted data sets, that is better, into a single sorted data set? So how would you combine multiple data sets which are individually sorted into a single sorted one? Let's say data set 1 is 1, 2, 5, 9, 12, and data set 2 is 0, 2, 2, 3, 3, 4, 5. Now if we have to combine these two data sets, right, how would you combine this? Lloyd says using cat and sort. If you do cat and sort, you will be, that will not be optimum. Okay, you are not using the property that the data is already sorted. Okay, here we use merge sort, and this is very important to understand, because otherwise if you see, if launcher has to sort the data again, what's the point of sending the data to machine 1 and machine 2? It could have done the sorting by itself anyway. If it has to resort the data again, then it could have done it already instead of asking machine 1 or machine 2 to do the sorting for it, right? Therefore, Nandini, did it make sense? Lloyd, Nandini, Suresh, Sanjay. All right. I will describe to you in merge sort in a very simple manner. Imagine that there are two queues in the prayer assembly, the first queue and second queue, and the people who are standing in these queues are standing by the increasing order of their heights. The first one is shortest and the last one is the tallest. So first one is shortest and last one is the tallest. Now there are two such queues and you have to create a single queue by merging them such that the resulting queue is also ordered, as in the person who is standing in the beginning is shortest and the person in the end is the tallest and everybody is in between. So if you have to do that during a prayer assembly, it should be very easy and straightforward. Do you remember doing that kind of thing any of your prayer assemblies? All right, so all you do is take the person who is standing on the in front, pick him, pick the shortest one from the two and create a new queue. All right, create a new queue, then compare the person who is standing in front with the another one and put it in another queue, the shortest one out of the two. All right. Now, again, you compare the people who are in the front, and and then you basically take both if both are of equal height. Okay. Again, you keep on comparing the same manner and keep on removing the shorter one from the head. Okay, from the beginning of the line, because those are the ones because you are standing towards the shortest guy. Okay, so you keep on removing them together, and when any of the one queues finishes, you take the second queue and put all the people in another queue. This is how you do the merge sort. Now, did you notice something? We did not visit a particular number twice, right? Which means this algorithm is linear. Okay, is the merge sort algorithm clear to everyone? Great, great. These are the most important fundamentals with respect to the computing. Although we must have read it during our education, but it's very important to brush it up. All right. So Rajesh is saying that can you come once again related to linear aspect of merge sort. So what we noticed just now is that we compared the heads and we kept on going. All right. So although we compared the second queue, if you notice in here, we compared first 4 with 5, then 5 with 5, and so on. Okay. A- and still the merging is almost linear. All right, because we are not visiting the multiple people again and again. All right, we were able to do it in a single shot. We started from the beginning of the queues and finished till the end. So this merging is far more easier than sorting the whole queues again. All right. Therefore, this merging is very important, and there are really good algorithms to merge. Okay, the one which we have used is very rudimentary. There are something called heap sort. Heap sort is basically creating a heap and keep on removing the node from the top. Okay, that you can have a look at your free time. So the launcher sends some records to machine 1 and machine 2. After getting the records from both the machines, it uses the merge sort and merges the records such that the result is sorted. Okay? And once the result is sorted, then it can do the summation again. Okay? So it will notice that ray has come from both the sides. All right, and ray has occurred this twice from the left and once from the right, and it will sum it up both of them after creating the combination. It will do the summation again and will give the word count to the end user. So does it make sense now? So we talked about four approaches. First one, in memory, good for few hundred MBs. Second one, the SQL and Unix one, where we moved the data from memory to the disk. That's the approach we have been using for quite some time. It doesn't work if the data grows bigger because the disk becomes the bottleneck. IOs becomes the bottleneck, and CPU also start becoming bottleneck. So we devised third mechanism. Fourth mechanism was to delegate the work of sorting to multiple machines, and then you do the final sorting. Sanjay says that this approach sounds like rudimentary distributing computing and MR. Good, good. All right. Now, what are the other problems do you see in this particular external sort? Anyone? Notice that, okay, launcher divides the data, sends to machine 1, machine 2. Some of you have already figured it out that there are problems with these approaches. Sanjay says it's rudimentary approach, and somebody has said, Sravna says that network traffic will become the bottleneck. Brilliant. Any other? Correct. I'm sending data to the node. Resource management failover. Brilliant. In case something fails, in case let's say the node 1 failed, node 2 failed, or whatever happened, maybe there's a network glitch for a millisecond and only one thing has failed. So the resource management will become the nightmare. Brilliant, brilliant, great, great. So these are the problems. So first is time consumed in the transport of the data is too high. Okay, every time we have to do something like a sorting operation or something like distributed computing, we are transmitting data again and again whenever required, which means the maximum of the time has been consumed in transferring the data. For each requirement, we will have to write a fresh program. This approach is okay, but every time some requirement comes up, you have to stitch your own program, and too much engineering will be required for that. It would require a lot of engineering to get it done correctly because it's not fail safe, it is not really, it doesn't have a resilience, right? So the solution is we use MapReduce, and MapReduce solves the problem really decently. Is everybody convinced why do we need MapReduce now? All right. So by the way, if you are wondering what exactly is this approach has been quite popular in the domains of grid computing. We did this kind of approach quite often whenever we did grid computing or cluster computing or whatever. All right. Everybody with me till now? Anandita, David, Jairam, Joshi, and Karthik, Lakshman, Lloyd, Mike, Nandini, Priyavrat, Rajesh, Ravikant, Sandeep, Sanjay, Sarvana, Suresh, Tushar, Vidya. Great, great. Now let's move on to the brief description of what exactly is MapReduce. All right, all right. So Under the hood, all of you keep, under the hood, MapReduce is a sorting machine, an ordering machine. Okay. Now, when it's an ordering machine, you might ask me the next question: on what basis does it order? That is defined by map. And once it has ordered, it has finished ordering. If you want to run something on ordered data, then how could you configure that? That is reduce. Again, I will come to this description again, but let's go into the usual verbiage, as in it's a programming paradigm to solve big data problems, specifically sorting intensive jobs. You would have to code two functions, mapper and reducer. Mapper takes the input and converts it into key value pair. And why does it do it? Because on the basis of the key, MapReduce will be sorting your data. Okay, on the basis of the key. Also, it's not only Hadoop although it was started by Hadoop, and the meaning of MapReduce has been as old as maybe 20 years, maybe more. Map and reduce come from functional programming, and but the meaning of MapReduce in context of Hadoop is a bit different. As we go forward till our discussion on Spark, your perspective of map and reduce would change a bit, but the philosophy will remain same. So it's not only Hadoop who is using MapReduce paradigm. There are systems like MongoDB, CouchDB, Cassandra, Spark. All of them provide some sort of a variation of MapReduce. Okay, but in strict term of distributed computing, the terminology of MapReduce was the contribution of Hadoop, not Hadoop, but based on one Google's paper on MapReduce. So Hadoop MapReduce is based on Google's paper on MapReduce by Sanjay Gemawat and Jeff Dean. All right. So the mappers and reducers. So when we say mapper, the role of a mapper is to convert input into key value pair. How would it convert? We will have to write program which returns key and value pair. All right. Reducer, how would it aggregate? We'll have to write program. Now this program of mapper and reducer can be done in Java, Shell, Python, or any of the binaries. Okay. It can be done in any of the binaries, be it Java, Shell, Python, maybe C++. Almost in every programming language, you can write your mapper and reducer programs. Alright, let's have a look at it, and then we will keep on moving one step ahead and try to figure out. Yes, that's what we are getting into, Karthik. Alright, so the mapper and reducer for the word frequency problem. Let's have a look at it. How does it look like? Imagine that there is a map function. What it does is it prepares the key value based on the input data. And the key it is giving out, if you see, for each word in the input, it is converting that into word, comma, 1. Word is the key, 1 is the value. Alright? Instead of 1, it could be anything, it doesn't matter, or it could be even null. It's completely okay. But what is important here in case of word count problem, that our map function is converting the data into key and the value. Why it's doing it? So that the data could be sorted based on the key. Alright, so you can think of Hadoop as a big sorting machine, or you can think of MapReduce as a big sorting machine which is basically seeking for something like what is the input data and on what basis do you want to sort it, and that basis is provided by your map function who is providing key and the value. Based on the key the data will be sorted, the value will be carried along. Okay, for example, let's say there was sa re saga will get converted into savan revan gavan, sa re savan and gavan. Okay, savan revan savan and gavan. Okay, so 1 is the value, sa is the key. Now, this dashed line basically represent what exactly is being done by MapReduce under the hood. MapReduce or Hadoop, you can say, it took the data and ordered it and grouped it. Okay, it took the data and ordered it. Now you can see that ga has come only once, sa is once, sorry, re is once, but sa is twice, and the data is ordered ga re sa. So it has done the sorting and the grouping. So it's like behaving like a group by, where the aggregation is nothing but forming an array. Make sense to you? And under the reduce function, these these two blocks are written by you. Okay, now your function says that for each word execute MapReduce will execute your function for each of the key, so that all the values for that key could be aggregated into a single value. Okay, so Karthik's question is sorting and grouping is done by the mapper. No, mapper is like I'm specifying the key and let it be done by the Hadoop, or let it be done by MapReduce paradigm, MapReduce framework, or whatever you can say. Application master, MapReduce application master is doing this sorting. All right. So the mapper basically is so as I told you, let me take a step back. So MapReduce is nothing but a big ordering machine, a sorting machine. It sorts the data, but on what basis? It could sort on binary data, but it gives you this luxury of specifying on what basis you can sort the data. And you specify that basis by giving out key as the key for any data. Right? On the basis of key, Hadoop will sort your data, group it, and for each group, it will execute your reduce. Make sense to you? Now, Sanjay's question is, can't we form the array or reducer directly reading the input file? Why to have mapper first? Okay. Sanjay, is your question still valid, or did you get your answer? All right. So can't we form the array? If we try to form the array, we have to first sort the data, right? We have to first sort the data. And sorting of the data has to be done by Hadoop, right? Because sorting is the most intensive process as we talked earlier. Now, on what basis it should sort? On what basis Hadoop should sort the data? That is decided by map function. Therefore, map function is handed over to Hadoop. that here is my map function, execute this map function on top of the data, and whatever result comes, you take it and do the sorting. And once sorting is done, please call my reduce function, and reduce function will combine the result of grouping. Okay, this grouping, the dash line, is done through via Hadoop. So Hadoop is doing this. So we provided a big input file, and we provided map function, and we provided a reduce function. Hadoop took our input data, found that okay, this is located on a machine, and here is your map function. It will run again and again on the input data parallelly on many machines, and then it will prepare the result after sorting. Here this is the result prepared by Hadoop, and then it will take your reduce function will and execute the reduce function on each of the key and values. So reading, sorting, and grouping is not the job of the mapper, it's the job of Hadoop. Mapper's duty is just giving out key. Okay, on the please sort my data on the basis of this key. That's the job of mapper. So reading, sorting, and grouping is done by Hadoop, and your mapper function is only used for converting the raw data into key and the value so that the data could be sorted. While once data has been sorted and grouped, it's in the nice shape, it will take your reduce function and will start combining the results. Make sense? No? Anyone? Before we move forward to anything else, I would like to clear this up. Is everybody clear? All right. So here is Karthik's question. It's a very interesting question. Let me put it here and also save it because you never know. All right. In this slide, both the functions are on single machine. If yes, then which function combines result from multiple machines? So this dashed line, you see this? This dash line is something which is being done by Hadoop on multiple machines, and this result is also gathered on multiple machines. Now this reduce function could also be done on multiple machines, while map function will also be done on multiple. You will see that in multiple machines context. All right. Sanjay is saying key can be unique or non-unique. You can see it here that key is non-unique, right? So sa is non-unique here. So sa has come twice. And in case it comes twice, it basically groups it together. If it is, I mean, only then the reduce function makes sense, right? Reduce function basically combines this one and one and produces something. Make sense, Sanjay? All right. Key doesn't have to be unique, or you don't have to bother whether it's unique or not. Because most of the time, if you knew that it's unique, then it's completely different picture. All right. Is this diagram clear? If you have any doubt, I would like to spend a little bit more time on this before we move to multiple machines and all the dynamics. Do you want to take a break now? Let's take a break for maybe. I'll just here only. Break for 10 minutes. Back by 10:15 p.m. IST. All right, let's take a break. Is everyone with me? Good. All right, so should we start now? All right. So Tushar's point is, so basically map is like a function to count words. Not really. So map is basically the function out of this, right? Map is basically converting the line into words. The job which was done by SED, okay? The map is a function which is equivalent of SED. SED converted the lines into one word per line, so that sort could, or you can say up to here, up to here. This is the duty of map. Basically, some data which could be sorted by Hadoop is the duty of map. All right. Any questions here? So map is just making the data ready so that it could be sorted. That's why it's giving out key and the value. On the basis of key, Hadoop will be sorting the data. Mhm. Any questions? Any questions? Yeah. All right. Or you could look at it like this. So we are not sorting the data. We are letting Hadoop sort the data. Okay. And whenever we talk about sorting, sorting could be alphabetic, sorting could be lexical, sorting could be in number of ways. Okay. That but so we can configure a sorting function. We can provide a parameters to a sorting function saying don't sort it by text, sort it by number. Okay, we could do that, but the sorting function can do its job provided we have told it that please sort our data based on this particular column, and please sort our data by numeric, not text lexical. All right, that's the duty of our map function. Yes. So Vidya is saying, so map converts unstructured data into a structured one. That will be a bigger debate. So I wouldn't use those words right now. All right. So basically, all map is doing is telling Hadoop on what basis it has to sort our data. Okay. So few things we have figured out that sorting can solve our problem. We have figured it out already that word count, instead of creating a hash map, can be better solved by sorting. Now, sorting on the basis of what? Each individual word, right? That's what our map function is doing here. So, actually, if you look at it, map function is not doing really much. All it is doing is taking the line, converting into one word per line. That's it. And rest of the job is being done by Hadoop, which is sorting the data, grouping it, and then on each group executing your reduce function. Yeah. Is there another function to sort the data? We are not sorting the data. We are letting Hadoop sort the data. All right. So we will basically control Hadoop by specifying different kind of keys. Okay, if we want, we can also tell Hadoop that, hey, don't sort my data by text, please sort my data by number numerically. Good. Sanjay's question is, key in key value could be a composite key too. Brilliant. Yes, it can be a composite key as well. The way, okay, the best analogy possible for whole map reduce is the the group by clause. Okay, so you can think of whole Hadoop as a big group by. Sorry, the map reduce part of Hadoop as group by. Think of the map reduce as group by. In the group by, what did we do? We said select word comma count star from the table and group by word, right? And if you look at it closely, what did we do? We told database, please sort my data and group it by first column. And then once you have formed the group, please execute count star on each of the group, right? In the similar manner, when we are writing MapReduce and we are executing the process, we are saying, please sort this data by word, this data which will be generated by map, please sort this data by the key, and whatever is the result of sorting, please group it, and on each group, meaning each word, an array of values, for on each of the group, please execute this function, right? That's what we are doing. We are requesting Hadoop, we are requesting Hadoop to basically sort the data, spit it out by map by the key which is being given out. And once that is sorted, this dashed line is something being done by Hadoop. And once it is sorted, it will group it. And on each group, the reduce function is going to get called. So in this example, reduce function will be called 3 times. First for ga, second for re, and third for sa. Okay, and all it's doing is summing up the values. That's all. Array dot sum means sum up all the full array, which means this will become 2 and rest will become 1 1 1. Okay, moving ahead. Now what if, now a little bit more detail. So in case of MapReduce, this input data sa re saga, what we have showed you, this data should be kept in HDFS. Now, if it is in HDFS, it might exist on two nodes, right? If you have a big enough file, if you have, say, 256 MB file, it will be on two different nodes. First block on first node, second block on second node. Let us say for the argument's sake. All right, the same map function what you provided will be executed against each line of text. This map function is going to be executed against each line of text on node 1 and node 2. If if node 1 had if node 1 had 1000 lines and node 2 had 2000 lines, so map function will be executed 3000 times. All right, going back, so map function, whatever it is here, it is going to get executed for each line in the input, and then out of each line it will convert the key values, and the same thing would happen if in case of multiple nodes. Now you can notice that when the data is on the same node and our map function is being executed on the same node, there is no network transfer, and effectively this map function will be really fast. Now, the sorting will happen on both the nodes. This is being done by Hadoop, this is being done by Hadoop, this is being done by Hadoop. All right. So there are two nodes containing one block each of that file. Our map is being executed on each of the node without having to transfer the data much. And once map is being has executed, it has given out the keys and values. It's sorted and then merged. After the merging, each group is being passed through your function. If there are a million groups, your reduce function is going to get executed a million times. All right. Now you can see that here we are only talking about one line. Okay. So on first node there is this line, on second node there is this line. Okay. When your map function, what does your map function do? It takes each word and converts them into key value. It just iterates them and prints them out as key value. So your map function on first node will convert this line into this, right? Similarly, your same map function is converting sare sa into savan revan savan, and after that it is being sorted on each node, node 1, node 2, node 3. Similarly, node 2 is also sorting the data, and after this third point the data is getting merged into the fourth step. So Ga has come once, Ray has come 1, 2, 1 comma 1, and Sa has got four values 1 comma 1 comma 1 comma 1. Now in the fifth one, in the fifth stage from fourth to fifth, for each of this group, this is group, right? All the values have been grouped together for key. So for each key and all the values, your reduce function is going to get executed. Okay, so your reduce function is going to get executed 1, 2, 3 thrice. Did it make sense? All right, let me answer your questions now. Okay, can you clarify how map is executed n number of times the sa re saga in node 1? So okay, so if node 1 had uh, say these many lines, this is 1 lakh lines, 100,000 lines, okay, and node 2 had something like 200,000 lines. So your map function will get executed 300,000 times. Right now we are just talking about a single line. Does it make sense, Lakshman? The way, okay, the way had there been a table with 300 300,000 records, and you say select column A 1 comma this from this table. Okay, you say this. Okay, then your this statement is going to get executed. Your, let's say, I call it say lower. Okay, we are converting the column into lower, so this lower function is going to get executed 300,000 times. In the same manner, your map function is being executed across on each record. Right now, since we are dealing with plain text, Record means a single line. Okay. Next question from Karthik is, if a map function runs 1,000 times for 1,000 lines, which component will combine the results of different map function on the same machine? Again, done by Hadoop for you. We will talk about how can your code combine the result. That will come a little later. Okay, for time being there will be some of newer function similar to reduce function. There will be something called combiner. Very good question. All right, Sanjay's question is, on the slide up till step 2, sorting is on different node. Where does the merge happens? Good. So this is where up to here you see the sorting has happened, and then there will be merge happening after step number 3, and the merge will bring all the data on to a single node. And after merging, the way I demonstrated that the merge sort will happen and the data will still remain sorted. So in the step number 3, the merging is happening after step number 3. All right. Now Sarvana's question is very good question. Where the reducer will run, who will decide that? Again, it's decided by Yan based on which machine is free. Based on which machine is free. Now, the another question from Sanjay is, can we have different MRs in tandem for the job? Yes, we can. Yes. Okay, I'll just explain briefly one more point which I missed here. So the data input to our map reduce process was from HDFS. This data came from HDFS. Block 1, block 2. Now the processing happened on block 1. The map converted it into key value. The map converted into key value. Sorting happened on both the nodes. Then it got merged. Then it got reduced. And the result of the reduce went back to another output folder in HDFS. Okay. Lakshman's question is MR looping line by line? That's correct. So no, let me explain again. So when I say for word in input, in case our when I said here that for word in input, it only got one line at a time. So the map function will get one line at a time because map function is being executed on individual line, not the full block in a single shot. Okay, that is something you have to keep in mind. Good. We have Anandita's question. Won't it be too much work for a single reduce function? So, or you can say single reduce node. If the way we are demonstrating that reduce function is being, so reduce function will be executed against all the word and values, right? Which means it's like too much of work. That is correct. Therefore, that's the next slide where I demonstrate how reduce function is being executed on multiple machines as well. All right. Is the output of map function always map reduce, or it can be in some other format? All right, so I missed the answering this question. Probably your question and his question is same. Yes, so we can have different MRs in tandem for a job or problem because the MR, the map reduce one, every map reduce job takes the data from HDFS and that get processed through MapReduce. Let's say MapReduce job 1, it goes into again back into HDFS. Then there could be another job, MR job 2, and there could be another, it would again go into HDFS. So that you can see it clearly that data is being pushed into disk and back and forth. Make sense to you, Lloyd? All right. This was, I think, Sanjay's question. All right. All right. Where is? I think I should increase the window size. All right. So next is the map function always map reduce or it can be in? So yeah. So the map function could be something like very blank. If your data is already in key value format, it may not have to do anything at all. And sometimes it could be complex. Similarly, there could be a reduce function and there could not be a reduce function. It's up to you. Oh, I misread your question. I misread your question. Is the output of map function always key value? Always key value, or it can be in some other format. So it has to be always key value. Basically, it has to be maybe a composite key, but you have to provide a key. Where value can be blank or null. So Ravikant's question is on which node is merge and reduce happening? Good question. Similar to what Anandita was asking. So no, it's a little different. So merge will happen on either on node 1, node 2. If there is node 3 which is free, merge could happen there, which means there is a transport expense here, right? Because the data is being transported to some third machine, right? But generally the result of map is quite small. So a lot of work has been taken care. All right. Same question from Sanjay. Sandeep's question is where all these 1 to 5 steps are executed in terms of nodes. So the map function is being executed on node 1, individual node. Similarly, map function is being executed on node 2. Sorting is happening on node 1 as well as sorting is happening on node 2. Then merging is happening either on third node or maybe on one of these nodes, okay, based on the yarn's computation. So if merge happens on one of these nodes, then data from only node 2 has to be transferred to node 1 because data from node 1 is already available there. So there is no network expenses. All right. Vidya's question is the the map on node 1 will be executed 1000, 100,000 and 2000 on node 2. Yes. In case in case there are these many lines. Okay. Map function is executed per record basis for each record in the input. In case of text file, record means a single line. Nandini's question is, let me take this question here. Very good set of questions. So up to sort the code goes to the data. After that, merge data and reduce it take into the new code. Yes. So this new node, so up to here sorting, the code is taken to the data. The map function which you wrote, right? Which you wrote has been taken to the node 1 as well as it has been taken to near the data. But after sorting has finished, the merge, for merge, the data is being transferred. Okay? It has to invariably transfer either from node 1 or node 2. So data has to be transferred. We'll go into more details as we go forward, as in how will this data get transferred. Yes, that's correct, Sarvana. So yes, yarn will try to execute this reduce function on either of the node, like node 1 or node 2, because the data is already there. But mostly, since node 1 and node 2 will be overloaded by the work of map itself, map reduce itself, so there are high chances that yarn will choose some other node which is free at this point of time. Okay, so there are two considerations by yarn. One is the data locality, other is the nodes which are free. All right, Lakshman's question is good. Good, let me explain. So the question is how Hadoop decides how many MapReduce jobs need to be run. Is it based on the merge sort data size? Okay, now imagine this. Here in this example, we assume that our file has got two blocks, which means our file is 256 MB. If our file was 1000 MB, which means there would be four blocks, right? Four blocks. If those four blocks are on four different nodes, that means node 1, node 2, node 3, node 4, right? And that means there will be four nodes which will be running our map functions. But the reduce function is something which is decided by you. So number of maps is decided by how many blocks are there. Okay, how many blocks are there, number of nodes on which maps is running is decided based on number of blocks, while the reduce function is decided by you. How many nodes should be running the reduce function? All right. Yes. So another question from Anandita is, are node 1 and node 2 are executed parallelly? That is, if sorting of node 1 is not completed, won't the reduce function execute? Alright. So it's little complex, but I'll explain. So node 1 and node 2 both are executing parallelly. Alright. And this merge will also start merging as and when data is arriving. But the final result of merge will only happen once both the parts have finished. Because because merge need data from both the sides. Correct? Good. So Karthik's question is a good question. While designing the solution for any big data problem, do we have to convert it into key value pair and then reduce? Yes. So in case your problem is only of map reduce, then yes. Okay. And basically whatever we discuss forward, you have to think in terms of all of those things. So now you are aware that how to store big file and how to churn it. Right now, the only thing we know is we can use MapReduce. But as we go forward, you will get acquainted with new technology and you will realize that most of it could be done without actually writing a single line of code. Okay? So stay tuned. This question is very big and it requires far more detailed answer. Good. So another question is from Anandita. Can there be multiple mapper and reducer? Yes. So you could chain, yes, we could chain them together. The way we did pipelining, similar way we could do that. So Sanjay's question is there something called in-memory MR? That is, instead of writing into HDFS, can we do it in MR in the memory? So this is what is being done by Spark. So Ravikant is saying no audio for me. I think everybody else is able to hear. All right. Lloyd is saying good, very good. Lloyd's question is that can merge be multi-step? If we have 100 nodes, can merge happen on 10 nodes and then on one node? So when we discuss about combiner, you will get the idea. Okay, so it can't happen that way. What happens is the merge starts happening just after sorting on each node. Okay, the merge is so we could run merge on both the nodes before carrying the data on a central machine. Good. In we have Sanjay's question. In MR execution, if map finishes but reducer fail, how is failover taken from this point onwards? So reducer will be executed on other node and will try to execute it based on the based on the error thrown by the reducer. Okay, it will try to execute it multiple times. If it fails, then it would give up and your whole map reduce has failed. It will not have any partial data. So there will be retries on multiple machines, on different machines, and then give up. Error, or you can say no result. So the whole effort of mappers would go waste in case reducer fail. All right. Uh, uh, Lakshman, could you mm, help me making your question little specific? Why does programmer needs to decide that? As in, you mean the number of reducers? Yes, the programmer need to decide the number of reducers at a number of times because programmer knows how much load is it's going to put on the reducer. Okay, if your job is not very sensitive to combining the data, then all you are looking for ordering the data, then you don't require a reducer, right? So programmer knows what kind of work he's doing and has to take the discretion on number of reducers. All right. So Vidya's question is, does map always work on entire file or is it possible to work on only part of the data like percentage of the data for quick analysis? No. So the map always works on the whole data. Just that in case of map, we could, let's say we want to sample our input data and only on the sampled output we want to generate the results, right? In those cases we could weave the logic, we could write that logic inside our map function. We could put something like a random number generator, and in case the random number generator has generated less than one value, then we spit out the results, otherwise we don't spit out the key values, otherwise we don't. So such kind of logics we can build into our mapper so that our mapper can skip the data. All right, in case you want your mapper to work on partial file, split it yourself and keep it in a separate file, and then you give that input to the map reduce. All right, good question again. All right, great. So any other questions on map reduce? Let me finish the next slides, and then I'll address your question again. All right, this is how you can think about it. Let's say there was a big file which has three parts: split 0, split 1, and split 2. Split 0, all records of split 0 means all lines of split 0 will pass through map. Similarly, all lines of split 1 will pass through map. Same function will get executed at three different machines, which means your code is being taken to the data. And same is being done at split 2, split 1, split 0. And this function, map function, is the result of map function, which is key value, is being sorted on key on the same, it's being sorted by the key and on the same machine. And once that has been sorted, the data is being copied to another machine, possibly because while all these processes are going on, the the selection of reducer, this node is most likely to be a another node. Okay, maybe on the node 4. So the data is being copied from all these machines to a fourth machine, and where the merge is happening, and then the reduce is happening, and afterwards the data is getting stored in HDFS. All right. So this was single reducer game. Now what if there are multiple reducers? Okay, let's say there is node 1, node 2. Okay, node 1 says Saresa, up to here everything is same. Just that just after merge shuffle, some records have gone to one node, some records have gone to another node. But keep that in mind, one group will always remain together, meaning It cannot be that some values for a particular key are on one node, some values are of a particular key are on another node. Okay, so it is guaranteed that the reduced functions are mutually exclusive. These two nodes get keys which are mutually exclusive. Otherwise, all the values will not be together, and if all the values are not together, that means our reduced function will not give the correct results. All right. Now, in another diagram, this is another diagram. All right. The way it happens, let's say, and this number of reducer is your call. Okay, so the data from mapper is sorted, kept in two buckets. Just after, as the mapper is giving out the results, some keys are put in one bucket, some keys are put in another bucket, and these buckets are carried to the different reducer. First bucket goes to the first reducer, second bucket goes to the second reducer. Similarly, on the second node, first bucket is going to the first reducer, second bucket is going to the second reducer, and so on. Now you see the difference? Alright, Karthik's question is, why would this situation arise? The situation would arise if this reduce function which you are executing is very intensive. This reduce function is being executed on a key and its values. If it's doing a lot of magic, it's doing a lot of hard work, your single reducer node could take a hit. Okay, could become really busy and could respond, your whole effort of map reduce might go waste. All right, let me take an example, probably that will clear your questions. Let me take an example. All right, let's take the case of this is an apple and this is a boy. Okay, node 1 contains this data. Okay, imagine that your block size is really small, something like 10 bytes is your block size. Okay, that means your two lines of text is, okay, let me put it first this way. So let's say there was a file like this which is put on HDFS and it became two blocks on two different nodes, node 1, node 2. Okay, now when this passes through your map function, it gets converted into this one is 1 and 1 and apple 1. Okay, now similar thing is happening here also. Similar thing is happening, which means it's given to the map function and map function is splitting this out and boy 1. Now this output of the map, whatever is this output generated, is being kept in two buckets. It's kept in bucket 1. Let me call it bucket 1. Okay, so this might go to bucket 1 and there could be bucket 2. All right, bucket 2, in bucket 2 is might go, then n might go here in the bucket 1, and in bucket 2 apple might go. Okay, Same is the case here. Same is the case here. All right. So the results of map are kept in two buckets. Okay. Here it might be, let's say, boy. Now the bucket one is being carried to the reducer one. That means these two have gone to reducer one, as well as these two from this one also has gone to reducer one. Okay. And reducer 2 contains these things. Okay. Second bucket has gone to reducer 2. Okay. Is an apple, is a boy. Okay. So if you sort it, let me fix it first. Yeah. So on reducer 1, this is actually comes as sorted. It is not, doesn't look like sorted here. Okay. It's all sorted. Here also it's all sorted. All right. So reducer 1 got some of the words from both the sides, both the nodes. Reducer 2 got some of the words from both the nodes. And then this has to be sorted because it's already sorted during on each node. All right. And on reducer, then the reducing process would start, as in combining these two, okay, combining these two and combining these two. Now you can see this is what happens. So just after map process has finished, the output is being kept in two buckets. Bucket 1 is being carried to the first reducer node, and bucket 2 is being carried. If there were 10 reducer nodes, and the number of reducers is decided by you, then if there were 10 reducer nodes, there would be 10 buckets on each mapper node. On each of the node, there will be 10 buckets. All right. Okay, so let me try to answer your questions now. So this means whole of the sorted and merged data goes of node 1 goes into reducer 2, but not some part of it. I think this is answered now, Tushar. No? Thank you. All right. So Sarvna, was this example good enough for you? Sandeep's question is, two separate buckets will not have similar keys. So yeah, same keys will not go into two different buckets. It won't happen that this, say, apple from this node went to the bucket 1 and apple from this node went to the second bucket. All right. Generally, this is under your control. You can define your partition and logic. Okay, we will discuss something called a partitioner, which will divide or which will decide which key goes into first bucket or which key goes into second bucket will be decided by partitioner. But till then, let's the default partitioner makes sure that one key always go in the same bucket. Okay, no matter what. So Karthik's question is, shouldn't we combine part 0 and part 1 again to get the final output? Now that's an interesting question. That's an interesting question. Now if you see, bucket 1 contain and this, and bucket 2 contains this, which means there will be two different files in HDFS doing containing the data. Now if you concatenate these two files, the result may not be sorted. We'll discuss it how to make it sorted later, but yeah, generally people don't need to concatenate the output of the reducer. If it is required, we can give the full folder as the input to the next phase of MapReduce. If required to concatenate these two files, we could use the HDFS append function, which can append the second file to the first one. Alright? But MapReduce will keep it in two different files. Alright? I hope that answers your question, Krishna. Alright. Does the reducer check as precursor that the merged data as its input is good data without any error? Does the reducer checks as a precursor that the merged data as its input is good data without any error? So reducer doesn't do that. Okay. Does the reducer check as a precursor that merged data as its input data? So yes, so those kind of things are anyway built in into the protocol, that in case there is a problem in the data transport, it will mark it as invalid data and data will be requested again from the node. Alright. What does bucket 1 contains and what does bucket 2 contains, which is separated? Now you get the idea, Anandita? Good. Alright. Sarvana's question is, on what situation sort goes into two buckets? Okay, it's decided by us. Number of reducers is decided by us. If our single reducer was very busy, we can create multiple reducers. So Sarna's further question is, who will decide number of buckets and on what basis? Number of buckets is a function of number of reducers, and the basis will be decided by the number of reducers is decided by you, and you will take this decision on number of reducers based on certain criteria. We will discuss it again soon. Sanjay's question is, how does HDFS knows node 1 and bucket 1 have similar object? It's based on the key, nothing else. Alright. Now Sarvana's question is, on what basis do we decide two reducers? And can you give an example? You will get to know it soon. Alright. There is a question, good question from Vidya, that can the output of part 0 and part 1 be assembled by a reducer without another map? That is something not possible. Right? So can the output of part 0 and part 1, if I understand correctly, that you are talking about two reducers output. Can we have, so let me say what you're saying. There was MR1 phase, they were map reduce one, there were some mappers and some reducer. They generated two parts, part 0 and part 1. What you want to do is give it to the reducer, give both the parts to the single reducer, right? That's what you're saying, right? So for this you'll have to create another map reduce process which will take both of these files as the input. All right, good. In the second phase, your mapper could be very could just skip doing anything. It could just say whatever is the result, give it to it's already key value, and key is we have already decided, and just give it to the Hadoop. Okay, so having no zero mapper doesn't make much of a difference. Sounds good to you? All right. So, do you guys want more examples of MapReduce before I give you problems? This was just one word count example. All right. So here are few questions for you, which you can work on before you come onto the second class. These are fairly easy as well as fairly difficult questions. All right. Let me try to explain each and every question to you. So the way we computed number of words, the word count, as in how many distinct words are there and how many times each distinct words have occurred. How many times each unique word has occurred in the text. That's what we meant by word count example. Alright? So here is the question for you. If you had to compute frequencies of letters, okay, from A to G. So if you just have to compute frequencies of letters in the input data, do you require MapReduce? So think about it and also mention in what circumstances you require a MapReduce for frequency of letter, and for what kind of circumstances you can get it done on the same machine using your normal program. Okay, so these questions are there in the LMS on no big data. Please answer there. All right. So do you require MapReduce for computing frequencies of letter A to Z? If yes, please write the MapReduce. Even if no, then also please write MapReduce. All right. Now Second question is find anagrams in Hughes text. Okay. An anagram is basically different arrangement of letters in a word. An anagram does not have a meaning. Does not have to have a meaning. So for example, cat, cat, act, and tech are the anagrams. Anagrams are different arrangement of letters. So your job is given billions of such words, meaning gigabytes of file, you have to find out the anagrams in the text. Okay, how would you do it? What will your map do? What kind of key will it spit out? Okay, such that all the anagrams should come together. Clear? Both the questions are clear to you? If you have any doubts about these questions, please ask now. No doubts? So you can clearly see that for the there is no anagram. For cat there is cat, tech, act. These are the anagrams existing in the text. Similarly for toe and in. Okay, there are no anagram available. Yes, thank you very much, Krishna. Yes, tick is missing here. I have updated it. Thank you very much. All right. Now, two more questions. So you have a file that contains the DNA sequence of people, and you have to find all the people who have identical DNAs. For example, user 1 ACGT, user 2 TGCA, user 3 ACG, user 4 ACGT. This data is in one file. You're given a file in HDFS containing this data without double quote, of course. Now, your duty is to bring user 1 and user 4 together because they have same DNA, same ACGT. Okay, how would you do it? What is the key and what is the value you will keep? What will your map function will do? What is your reduce function do? What will your reduce function do and what will your map function do? Okay, now the next question. This is little tricky. Some scientists figured out that people whose DNA is either identical or mirror image, as in isotope. So if me and you have same DNA or completely mirror image, meaning completely reverse DNA, then me and you are from the same family. Now, given this data, you have to bring the families together. So user 1, user 2 and user 4, all three of these users have either the same DNA or reverse of each other, which means you can see that user 2 is exactly reverse of user 1, ACGT and TGCA. Okay, so your job is to find out, you have to bring the people together who belong to the same family, meaning all the people whose DNA is either identical or reverse of each other. So Lloyd's question is, do we have to write code or just steps? You just have to write pseudocode. Okay, clearly mention what am I looking for is clearly mention what is the key and value in case of map function, and in case of reduce function, what is it going to do as aggregation. All right, now the last problem. So there are total number of how many problems? Uh, 5 problems. All right. These are fairly difficult problem to solve, and they cover most of the problems. In this unusual democracy, everyone is not equal. Okay, there is a strange democracy in which everyone is not equal, which means not everyone has equal voting rights. The vote count of the rich matters most than the poor one. Okay, so the vote count is a function of the worth of the voter. If you have got 10 lakh 10 lakh rupees in your bank account, you get 10 votes. Okay, so your vote count is a function, the vote count is a function of the worth of voter. Though everyone is voting for each other, all right, everyone is voting for each other. You can see this example where A with a worth of 5 and B is a worth of 1 are voting for C. So the vote count of C is 6, meaning 5 plus 1, the worth of A plus worth of B. So whosoever is voting for C, the worth of vote count of C will be summation of the worths of individual voters. Now you are given this list of people with their value of the vote, and you are also given another list containing who voted for who. So list 1 contains who voted for who, list 2 contains who has got how much worth. Now your duty is to find out the total vote count of individual voter, individual, individual contestant. Is it clear to you? You can see that A got nothing, B got nothing. C was voted by A and B, therefore C has got a vote count of 6. F was voted by only C and C's worth is 11, therefore F got 11. Make sense to you? So you have to find out these assignments. You have to find out the vote counts of individual and finish these 4 assignments. All right. You want me to solve some problem? Some more example do you want? All right. Now here is a good question for you. Let me try to frame some random question. All right. All right. Do you have any question in mind? I can try solving it for you. Let's say you are trying to build crossword assistant. All right. You are trying to build crossword assistant. And what you want to do is you want to build a big list of first letter, okay, and number of letters. So given that basically what you want to answer at the end of day is what are the words starting with something, a single character, and having many characters. Okay, so basically you this is what you are trying to do. you are given the full dictionary, and you want to build a kind of a table such as A1, how many words are there of one length. Okay, what are the words which are of one length and are starting with A? Similarly, how many words are there that are starting with A and has got two length? Similarly, A3, A up to say A15. All right. Similarly, you want to build B1, B2, and so on. Is the question clear, or is it too straightforward? So basically, in the map function itself, you are going to do is pick the first letter, pick the first letter, and let's call it C equals pick the first letter, and L equals to length of the word. Print C appended by length. Okay, C appended by length, and then the actual word. Okay, that's it. That's correct. So I think that was very straightforward. I think I should have taken a better example. Or if you have something in mind, you can tell me. Or let me try to explain a really, that is going to be really very difficult. So if you want to see some of the really tough ones. So I've done a massive matrix multiplication using the MapReduce. Okay, so that it can multiply billion rows by billion columns. Okay, so you can have a look at this approach as well. All right, so basically in these four questions, all I'm looking from you is the what will be the key and what will be the value. All right. So this is one program which I wrote, and here is the command line to execute the same thing, and it should work. All right. So that was our discussion on MapReduce. We will continue it in the next session. All right. Any questions at this point? Yes. So that was a mistake. Uh, that was a mistake, and sorry about that. Priyabharat is saying that can you please explain the second problem? All right, let me explain the second problem. All right. So the idea of a first, what is an anagram? Anagram is a different arrangement of letters. Okay, so can and neck are anagrams. Okay, different arrangement of, not really opposite, or even this is an anagram. NCA and can are anagrams. Okay, so I hope the definition of anagram is very clear to you. Red, art, tar, and who can help me? Tra. These are all anagrams. Okay, so given a huge text, what are the words which are anagrams of each other that are existing in this text that you have to find out? You have to bring all the anagrams existing in this text together. You have to bring all of such anagrams together. Okay, all those anagrams which are existing in the text, you have to bring them together, like the way we have brought cat, act, and tact together, while there is only the, for which there is no anagram, toe, in, and tick. Make sense to you? All right, great. Have a good day, and see you next week. It's a great, vibrant class. I'm thoroughly enjoying your questions, and if you have any doubt, any questions, please feel free to ask. Do not get bothered by that the time we are going slow or something like that. Don't get bothered by that. We will we are going at a very good pace, and this is good to have. Okay. I mean, having such a great set of questions from all the students is something I really appreciate. All right. Have a good day. Bye bye. Thank you very much. Thank you, Shravana. Good night. For you, it may not be good night. So for submitting, you can just go to the website. Under there, you will find there will be, all right. There will be my courses. Under my courses, you will see the session number 2, and there is a this is the same quiz for session number 3. Yeah, there is the subjective questions. Okay, so for me, because I was on the, so you can submit using this one. All right, you can just type your answer here. That's it. Bye bye, have a good day.